Okay. Suppose the ERB grants your firm a license to directly sell electricity to consumers, as indicated by an estimated residential demand function for electricity. Okay, so as we can see, this is a demand function for electricity. So electricity is the good in this case. All right. We have QD equals 12,000. This 12,000 represents when the price of electricity is zero, the price of goodwill is zero, your income is zero, and what the advertising is also zero. Okay, this is how many units of electricity demanded. This negative 3px. Px, as the question says, Px is the price of the good. Okay, in this case, this is the price of electricity. So as you can see, where the amount of electricity consumed sells for 0.44 per unit. Okay, so that's the price of electricity here, Px. Okay, and good Y sells for 1 kwacha per unit. Okay, good Y is another good. They haven't told us what it is. The company utilizes 2,000 units of advertising on public information campaigns. So A, this presents this advertising, and consumer income is 10,000. So M represents income. So colleagues, I'll go through the demand function again. PX, the price of electricity. PY, the price of good Y. M is the income. A represents advertising. Now, before we go to answering the question, there's a lot of things that we need to understand about such demand functions. Okay, this demand function, okay, our quantity demanded for electricity, which is QTX. Just mute your mic. Just mute your mic. Our quantity demanded for electricity is dependent on the price of electricity, PX. It's also dependent on the price of good Y. It's also dependent on the income, and it is also dependent on advertising. Okay, the quantity demanded of electricity is dependent on those four factors. Okay, so the first part of the question says, how much electricity should consumers purchase? So basically, what we're going to do here is these values here, this 0.44 per unit, we substitute it with PX. This 1 kwacha, we substitute it with PY. This 2,000 units, you substitute it with A. And this 10,000, you substitute it with M. That will tell us how much electricity the consumers need to purchase. So let's get our, hope you've come with papers and pens. So we're going to say, so solutions here. Number one, so QDX, quantity demanded for electricity, equals 12,000 minus 3. So PX was substituting it with 0.44 plus 4PY. So PY, we substitute it with 1. So 4 here. 1 minus M, which is 2000, plus 2, then AX is substitute. Wait, M was what? 10,000. So it's 10,000 here, not 2,000. 10,000 here. Then 2 times 2,000 here. A is 2,000 units. Okay, colleagues, let's get our calculators. What is 3 times 0.44? 3 times 0.44, what do we get? Mr. Manasseh, Madam, let's see, Madam who? Madam Jessica. Okay, let me solve. It's okay, I'll solve. So 3 times 0.44, that is 1.32, plus 4 times 1, that is 4, minus 10,000. I should have left it in green. Plus 2 times 2,000, 4,000 here. Okay, so we can do it like this. We start 12,000 minus 1.32 plus 4 minus 10,000. I'll just give the final answer at the end. Plus 1,000. 6,002.68. That's the answer I'm getting. No, it's just 10,000. So 6,002.68. So this is how much electricity that needs to be purchased. Any questions? Okay. Are the Part 2, are the quantities of electricity and Y substitutes or complements? So here, how we're going to tell this is we're going to look at our demand function, okay? And we're going to look at the sign before PY, okay? Because PY is representing the price of good Y, okay? So here you can see that there's a plus sign before PY, okay? So here, if we isolate the quantity demanded of electricity and the price of PY, okay? If we look at these two in isolation, okay? What this positive sign is telling us is that if the price of PY goes up, the quantity demanded of electricity is also going to go up. Okay. And if the price of PY goes down, the quantity demanded of electricity is going to go down. Okay, that's what this plus sign means, a positive relationship. In a positive relationship, when one quantity increases or one unit increases, the other one is also going to increase. Okay, if one decreases, the other one is also going to decrease. So now here, colleagues, what is a substitute good and what's a complementary good? So that we're able to tell what type of good, if these goods are complements or substitutes. What is a substitute good? That's yes, that's a good illustration. Mr. Manasseh, have you got that? Complement goods, these are goods that are used with another good. By themselves, they are of no use. Uh-huh. Phone and a SIM card, car and fuel, bread and butter, phone and a screensaver. Those are examples of complementary goods. So if we let's look at a phone and a screen protector. Okay, if the price, and in this example, we're just assuming there's only one type of phone, one type of screen protector. Okay, so if the price of phones goes up, what do you think will happen to the quantity demanded of screensavers? Not screensavers, screen protectors. If the price of phones goes up, what will happen to the quantity demanded of screen protectors? Oh, Madam Jessica. Mm-hmm. Uh-huh. Yes, it will go down. Yes, the quantity is going to go down. So there, that's like a negative relationship. I've seen price has gone up of one good, quantity demanded of another good has gone down. So that's a negative relationship. Okay. So if this PY had a negative sign here, would have said this is a complementary good because with a negative sign, if the price of PY goes up, it means also quantity demanded of good X is going to go down because these two goods are complements. All right. So when you see a positive sign like this, it's indicating a substitute good. Okay. Example, in this example, let's say Coca-Cola and Pepsi. If the price of, we assume they're priced at the same amount, there are no other drinks in the world, just those two. If the price of Coca-Cola goes up, it means people stop buying Coca-Cola and go for the cheaper Pepsi, right? Meaning quantity demanded of Pepsi is going to go up, right? So price of one good has gone up, people have substituted it and gone to the other good, so quantity demanded of the other good is going to go up. So this is a positive relationship shown by this positive sign. So electricity and good Y are substitutes. Okay. they are substitute goods. Any questions? Because of this positive sign here that has told us that. Any questions? So they are substitutes because the coefficient of py, okay, has a positive sign. Coefficient is just the number before py. The coefficient of py has a positive sign, so we say they are substitute goods. Any questions before we go to the next one? Okay, number 3. Is electricity a normal or an inferior good? Again, here you have to come back to the demand function. Okay. So for normal and inferior goods, focus on income, the relationship between quantity demanded and income. So now, colleagues, what is a normal good and what is an inferior good? Hey, Mr. Manasseh. You have used the wrong variables. It's not price and demand. It's income and quantity demanded. Yes. So a normal good, if your income increases, you buy more of that good. Okay, so if your income increases, it means quantity demanded of that good will increase because you can buy more of that good. All right, there are a lot of normal goods: sugar, tea. There are many normal goods. Okay, bread, mealy meal. All right, and when your income goes down, it means you also buy less of that good. So quantity demanded is also going to go down. All right, so it means for a normal good. Expect a positive sign. Okay, because what we're saying is when income goes up, quantity demanded of the good has to go up also. So they're moving in same direction, positive sign. When income goes down, quantity demanded also goes down. All right. Now, what is an inferior good? Which one is that one? Yes, when your income increases, you buy less of that good. And when your income decreases, you buy more of that good, signaling what? A negative relationship, right? Between income and quantity demanded, right? Yes. So in our inferior goods, cachasu, is a perfect example. I wouldn't want to say carpenter because people, there are those people who eat carpenter. So I wouldn't want to upset people who watch this video in future. So, okay. So yeah, chunks also you find that people who have got money and also eat them. But okay, for people who watch this video in the future, we are not trying to hurt you or whatever. It's just for this economics class. So yes, we can put carpenter and soya chunks. Okay. When your income increases, you stop buying carpenter and soya chunks. You buy now the sausages, the T-bones and everything. When your income goes down, you find now you're back to buying soya chunks and things. So in this case here, with this question here, we've seen there's a minus sign in front of income, meaning if income goes up, this person quantity demanded of electricity is going to go down. So what type of good is electricity in this case here? Because of the negative sign here on M for income. So when income increases, quantity demanded of electricity goes down. So in this case here, is electricity a normal or an inferior good? Yes, in this case, it's an inferior good. Okay. Though in real life, I don't think we can call electricity an inferior good. Because if your income goes up, you buy more units of electricity. When your income goes down, you buy less units of electricity. Okay. But for this example here, it's an inferior good. Why? Because of this negative sign here. Okay, because of this negative sign. Now, this next part is not part of this question, but you encounter such questions in managerial economics. Okay, the elasticities, price elasticity of demand, income elasticity of demand, cross price elasticity of demand. These elasticities also be able to tell us whether goods and if it's income elasticity of demand, it will tell you whether a good is normal or inferior. If it's cross price elasticity of demand, it will tell you whether a good is a substitute or a complement, right? And if price, then what's this? Price elasticity of demand, it will tell us if demand for the good is elastic or inelastic. So I want us to look at that using this same demand function, okay? Using this same demand function here. If this, let's say we put question 4, calculate the price elasticity of demand for electricity. So let's put question 4, calculate the price elasticity of demand. So colleagues, do we remember what price elasticity of demand means? Do we remember what price elasticity of demand is? Eh, Price elasticity of demand is how quantity demanded of a good responds to changes in prices. Okay, responds to changes in prices for the good. Okay, that's price elasticity of demand. Okay. So price elasticity of demand tells us two things. Either the good is elastic or if the good is inelastic. If demand for the good is inelastic. So here when we talk about elastic or elasticity, we're just talking about how something responds, how quantity demanded basically responds. Okay. Whatever elasticity you're dealing with, it's all about how quantity demanded responds to something. That can be the price of the price of the very good, the price of the other good, or the income. Okay. So when we say demand is elastic, it means if quantity demanded is very responsive to changes in prices, okay, or it's you can think of it as it is sensitive to changes in prices. So when demand is elastic, for example, if you increase price even by let's say 1%, okay, increase price by 1%, quantity demanded will drop by a greater amount due to the law of demand. Okay, so if price goes up by 1%, then for example, quantity demanded can go down by let's say even 10%. Okay, maybe even 12%, 13%, or 20. Because it's showing us that the quantity demanded is sensitive to changes in price. Okay. If price, let's say, goes down by even, again, the same 1% due to the law of demand, quantity demanded is going to go up by a greater amount, let's say, even 15%. Any questions on this, on elastic demand? Ben, when we say demand is inelastic, it means quantity demanded is not sensitive to price changes. So, for example, price can even go up by five. Let's say price can even go up by 10%. Okay, say price goes up by 10%. Then you find quantity demanded might drop just by 2%. Okay, price goes up by 10%. You find quantity demanded just drops by 2%. Okay, here what we're saying is that quantity demanded is not sensitive to changes in price. Okay. So if you're given a question where you're just given one demand function, and they ask you to determine the own price elasticity of demand, this is the formula you use. You partially derive the demand function Q dx with respect to the price of good X Px. Then you're going to multiply that by the price of good X over the quantity demanded. Okay, over the quantity. This is how you get the price elasticity of demand, PED. Okay. In microeconomics, I remember we were doing percent change of quantity demanded over percent change of price. You only use that one if you're given the price before and the price after, the quantity before and the quantity after. But here, you've just been given one price and you've also tabulated one quantity. So in this equation here for price elasticity of demand, Px you don't need to calculate because they've already been given. Px is 0.44. Q is the demand we calculated here. How the quantity. How much electricity should the consumers purchase? We calculated 6,002.68. So Q we've already calculated. Okay. All we need to do is now we need to derive this demand function with respect to Px. Maybe when you're deriving, whatever doesn't have a Px, Are you able to see it now? I'm still sharing it. Yes. Are you able to see? Are you able to see it now? Try to log out and log in. Try to log out and log in. Okay. Are you able to see it now? Madam Wangala, are you also able to see this presentation? Are we able to see the presentation? They've been all being kicked out. Or maybe they are rejoining. So are you able to see the presentation? Okay. Let me just finalize because I've got another class at 21. So I was just calculating the price elasticity of demand. When we meet next time, we'll get the cross price elasticity of demand and income elasticity of demand. Okay. Yes. So I was saying for price elasticity of demand, we are going to derive this demand function with respect to Px, meaning whatever doesn't have a Px disappears. So this goes, the M goes, the 2 x goes. You're just remaining with this negative 3px. So you need to derive it. So remember, this px is like p to the power 1. When deriving, multiply the exponent by the coefficient. 1 times negative 3, that will give you negative 3. Then you subtract a 1 from the exponent. So 1 minus 1 gets 0. So your answer is negative 3px to the power 0. Now anything to the power 0 is 1, so you don't even need to show that. Okay, you do not need to show that. Our answer is just negative 3. So here for price elasticity of demand, we want to get price elasticity of demand for this electricity here. We derived the demand function. So here we got negative 3 times, okay, this expression here just comes down to negative 3 times px 0.44. It was given to us in the equation here. The price of 1 unit of electricity is 0.44. So px over 6,000, 6,002.68. Yeah. So calculate the price elasticity of demand. 0.44 divided by 6,002.68 times negative 3. Times negative 3 will get negative 0.0000219. Now with price elasticity of demand, you always have to get the absolute value. The absolute value is where you ignore the negative sign. Why do we need to always get the absolute value? Because due to the law of demand, okay, Price of the good and quantity demanded of the good are going to have a negative relationship, ceteris paribus. So because of this negative relationship, when one quantity increases, the other one goes down. So that whatever variable go down is going to give you a negative value. Okay. So basically, every time you be calculating price elasticity of demand, you always be getting negative values. Okay. So now, since you always be getting negative values, that's why we need to get the absolute value so that you can easily interpret the number because all negative values are less than 1. So it means every time you be calculating, you'll be getting, um, yes, since all negative values are less than 1, and you always be calculating negative values when calculating price elasticity of demand, it means all the time your demand will be inelastic. Okay, because every time you're getting a negative value, so it will be like always your demand is inelastic. So to avoid situations where every time your demand is being inelastic because of the negative sign, you get the absolute value of your price elasticity of demand. Meaning you just ignore this negative sign and you say price elasticity of demand is 0.0219. And how we interpret this, since our price elasticity of demand is less than 1, so we're going to say demand for electricity is inelastic. Meaning if the price of electricity goes up, quantity demanded is not really going to be sensitive. Any questions before we close the class?